class we have discussed regarding the problems on average criteria. Today we shall see the question paper, that is control system question paper. They have given question like this. This is in the year this is a 6-sem question paper. So this is they have asked in the December 2019 and Jan 2020. Okay. So this is a question what they have asked in derive an expression for rise time and peak time for second order system excited by step input. In bracket they have given under damped case. Okay. So before going to that topic, first we shall know the time response specifications. Okay. These are the five specifications. One is delay time, second is rise time, peak time, and maximum overshoot, and the fifth is settling time. So you can observe this is the rise time from 0 to it is up to 1. Okay, and after that what this is the peak overshoot. So from year to year it is a peak time, and from 0 to till here it is a settling time. What do you mean by delay time? The delay time is the time it is required for the response to reach a 50% of the final value for the very first time. Okay, so this is the delay time, TD. So this is a 50% of the final value for the very first time. So you can see here 0.5 to what? This is off of the 50% of the final value. So that we call it as a delay time. Okay. Initially, it takes time to increase the value of C of t. Okay. So from 0 to till here, how much time it will take? That is the delay time. And next, rise time. The rise time is required for the response to rise from 0 to 100%. This is delay is 50% and the rise time is from 0 to it is 100%. So you can observe here 0 to 1. Okay, that is what 100%. That is the rise time. And next is the peak time. That is peak time is the time required for the response to reach the first peak of the overshoot. And the maximum overshoot is the peak or maximum overshoot is the maximum peak value of the response curve measured from unity. It is the final steady state value of the response differs from unity. Then it is common to use that maximum percentage overshoot. That we can write it as C of TP minus C infinity divided by C infinity into 100. Next is the settling time. Here the settling time is the time required for the response curve to reach and stay within a range. Okay. About the final value of a size specified by absolute percentage of the final value. So for example, settling time is it is the how much time it will take to how much time it will take for the response. Okay, response curve to reach a final value. Okay, before the final value. So settling time is the time required for the response curve to reach and stay within a range. Okay, if they have given the system for a range, for example 1.5 or anything like that, so within the range. Okay, stay within a range about the final value of a size specified by absolute percentage of the final value. That is usually they go with the 2 or 5%. for example, if they have specified that what I said. So final stage, that is the settling time from initial stage to final stage, that we call it as a settling time. Steady state error. It indicates the error between the actual output and the desired output as t tends to infinity. We can write it as ESS equals to limit t tends to infinity R of t minus C of t. These are the just definitions of the time response specifications. Now we shall do the derivation on that. Okay, expression for time response specification. First one is rise time. So the output of a second order system under damped system excited by a unit step input is given by. So this is a standard formula for the second order system, second order under damped system which is excited by a unit step input. Okay. Unit step input means R of S equals to 1 by S like that. Okay. So C of t equals to 1 minus e to the power of minus zeta omega n t divided by square root of 1 minus zeta square sine omega dt plus theta. This is the standard formula for second order system and for under damped system. So for rise time, it is defined as the time taken by the output to rise from 0 to 100%, right? So what you will substitute T equals to TR, C of TR equals to 1, okay? So when you substitute that, what you will get so C of T equals to 1. So 1 minus e to the power of, instead of T, what you will substitute TR, okay? So what you will get 1, 1, it will become 0, okay? So e to the power of this equation equated to 0 now. So whatever in the denominator, that will become in the 0. Okay. So this part will be 0 because sine omega d dr plus theta equals to 0, that is equals to sine pi. Okay. And this is not equals to 0. What they are saying is e to the power of minus zeta omega n dr divided by square root of 1 minus zeta square is not equated to 0. And this is equated to 0, and what you will get sine pi. Okay. Omega d dr plus theta equals to pi. Sine omega, from this equation what we can write, pi equals to is nothing but omega d dr plus theta. Okay, omega d dr plus theta equals to pi. Omega d dr equals to pi minus theta. What is the value of tr? Tr equals to pi minus theta divided by omega d. So from the angle like this is the this value is 1, and here theta. Okay, this value is here. Okay, so tan inverse of, so this is the theta here. This is theta. So opposite is square root of 1 minus zeta square. Here actually 1 is square root of 1 minus zeta square. So when you write tan theta equals to opposite divided by adjacent, square root of 1 minus zeta square divided by zeta you will get. So pi minus tan inverse of square root of 1 minus zeta square divided by zeta. And omega d value is omega n square root of 1 minus zeta square. This is the value of PR, that is rise time. And peak time, the output of a same standard equation you need to take, and T equals to, replace the instead of T, TP, and slope of C of T must be 0 here. So differentiate with respect to T. So T equals to TP, that is equals to minus e to the power of minus zeta omega nt square root of 1 minus zeta square. When you differentiate sine, what you will get cos omega dt plus theta into omega, because you need to differentiate inner term also, minus sine omega dt plus theta e to the power of minus zeta omega nt square root of 1 minus zeta square minus zeta omega n. this is u into v rule. This is a u and this is v. Okay, so this is v dash u into v dash and minus what we got plus v into u dash plus, okay, that is what we have done here. So theta omega n sine omega dt p dt plus theta minus omega n square root of 1 minus zeta square cos omega d dp plus theta equals to 0. So this equated to 0. Okay, this is equated to 0, this is equated to 0. So what you'll get, minus into minus, this will become positive. That's why they have written at the starting. Okay, and this is the negative value, and that's why they have written here. Okay, so instead of writing the omega d, they have just substituted the omega n square root of 1 minus zeta square. Next, zeta omega n sine omega dt dp plus theta minus, here they have cancelled the omega n. Okay, cancel it omega n, letter as it is you need to write. Next, instead of writing zeta and instead of writing square root of 1 minus zeta square, you can write down cos theta and sin theta. Okay, this formula, this cos theta into sin theta into cos theta, that can be written as what? Sin a plus b, like that. So what you'll get, sin omega dt p plus theta minus theta. Okay, so what you'll get, theta get cancelled, you'll get 0 because sin omega dp equals to 0, that is equals to sin pi. So what is the value of pi here? Pi equals to omega b into tp. But what is the value of tp here? Tp equals to pi divided by omega b. T overshoot, same formula you need to substitute. And here mp equals to c of tp minus 1. So what you will get when you do minus 1, 1 will be get cancelled. So minus e to the power of minus zeta omega n pp plus square root of 1 minus zeta square sin omega d pp plus theta will be remaining. So here substitute the value of tp. So tp equals to what? Pi divided by omega d. Omega d will be cancelled. So sin pi plus theta. So what is the value of sin pi plus theta can be written as here minus sin theta. So e to the power of minus pi. This omega n will be cancelled. Minus pi zeta square root of 1 minus zeta square whole divided by 1 minus zeta square into square root of 1 minus zeta square. So sin theta can be written as 1 minus zeta square. Minus into minus will become positive. This is the value of the overshoot. So if you want in a percentage, you can multiply into 100. Okay. These two will be cancelled, so you left with only the e to the power of minus pi zeta divided by square root of 1 minus zeta square into 100. It is the peak overshoot. Next, settling time, same equation you consider. Next, e to the power of minus zeta omega n p square root of 1 minus zeta square equals to 0.02 s. That is, here they have written that if it is 2% criterion, ES equals to 40, that is equals to 4 divided by sigma, that is equals to 4 divided by zeta omega n. 2% criterion. If it is a 5% criterion, 3 divided by zeta omega n. These equations for obtaining are valid only for the standard second order system. And finally, steady state error. So C of t equals to 1 minus e to the power of minus zeta omega n t square root of 1 minus theta square sine omega d e plus theta. ESS equals to limit t tends to infinity, E of t equals to limit t tends to infinity. Substitute the value of E of t is nothing but 1 minus C of t, that is equals to C of t value is nothing but again e to the power of minus zeta omega n t square root of 1 minus zeta square sine omega dt plus theta, that is equals to 0. This is the steady state error. In next class, we shall discuss with the second order system. So for this question, what you should write is, so you need to derive the derivation for rise time and also for the peak time, TR and TP. Okay, if they ask for peak overshoot, so you should find the peak overshoot also. Okay, in next class, we shall discuss with the